this one here. I'm not a biologist, but you'll see it in this form, so it's nice to kind of see it in both forms. So when you have this information, for example, you can never find the mass number of an element off the periodic table. You can look and look and look. Molybdenum, where's the mass number? It's not there. Cobalt, where? No. No, there's nothing on it. Okay? So, why? Because they're isotopes, and there's like chromium has 4, so they're not going to put all 4 on there. Okay? They're going to give you the average atomic weight, but they're not going to give you all of them. So, in a problem, they'll give you the mass number directly or indirectly where you can calculate it. Okay? So this one they give it to you directly because this here is the mass number. Okay? Where's it on this one? Top left. This is the mass number. Okay? And so the mass number is, remember what's that? So it's equal to protons plus neutrons. Okay, so that's the mass number. Okay, so here's what I noticed in the other class. They were doing this. Okay, so the atomic number comes from the periodic table. This is the mass number. So that would not be right. Don't do that. Don't put that in there. Okay? So where do you look at, and you'll always get it right. Where do you look at on the periodic table to get the atomic number? Top left. So what's it for silicon? 14. Now that is also the same as protons, 14. Okay? Now you guys can see that this charge at the end says it's 0 because these two are the same. If they're the same, then they cancel each other out. Electrons cancel out protons. Okay? Now, what would the charge be if we had more electrons than protons?
Negative.
Negative. And then if we had fewer electrons than protons, it'd be positive. Okay? So let's say we have 3 fewer electrons than protons. What would the charge be? 3 fewer electrons than protons. What would the charge be? Positive what? 3. Okay? What if we have 2 more electrons than protons? What's the charge? Negative 2. Okay? So let's just do this one across. What's the atomic? Now, on these here, you don't have to look at the periodic table. But if you want to, you can. You just look up aluminum, and it is atomic number 13, which matches up with this bottom number. So this bottom number is the atomic number. But you don't, that's why I like it in this form, because I don't even have to look at the periodic table to do any of these that are in these forms. So that's the atomic number right here. So atomic number what? 13. Electrons. Oh, we got a +3 here. So these have to be different. So is this going to be 16 or 10? 10 because we got 3 more protons and electrons. If I put 13 in there, that means 3 more negatives. That would mean a -3. I can't have that. Okay? What's the only one that changes? You never change the number of protons once you have them down because that indicates the atomic number and that won't be different. You have to change the electrons. Okay, so neutrons is the difference between these two. So I would have, these are 13 protons and this is protons and neutrons. So I'm going to have to subtract out what? 13 to get rid of the protons. So that's 14, right? Questions? Okay, so protons and neutrons equal mass number. If I want to know neutrons, I subtract the 13 from it to get neutrons. If I want to get the charge, if it's negative, I add more electrons. If it's positive, I want to have fewer electrons. So go ahead and do the next two, and we'll see what you come up with for the next two. These next two go across. So go ahead and fill those in. you have to have your periodic table out. That'll help. Or you can look up there. Okay, because if you don't have your periodic table and you do this, on the next two, you're not going to know what's going on. So you've got to have your periodic table out. Here, while you're doing that, just listen. Students will do these wrong because they won't pay attention to their headings. And they'll start putting numbers down, and then they're assuming they're putting it in the mass number column when they're putting it in the atomic number column. They're actually thinking right, but they're putting it in the wrong column because they're thinking the columns aren't labeled in the way that they're supposed to be putting them in, and so they just get mixed up. Okay? That's one thing that they would do. Alright? Protons are always on the periodic table. You just have to look at that top number. The mass number is protons and neutrons added up. That's all you have to do is add them up. If you don't know, if you know the mass number but don't know the neutrons, you have to subtract out your protons. Okay? And the charge is basically the difference between protons and neutrons. If you have more electrons, it's negative, that number. If you have more protons than electrons, it's positive, that difference. And that's really all you're doing on this. Okay? So the first one, what element is it? Xenon. How do you figure that? Protons. Protons is the top number. It corresponds to 54. Okay? Right. If you don't know, you look at 54 and you find it on the periodic table. Top left number. Okay?
Oh.
That is xenon. Okay? And that would be the atomic number as well. So I'll put Xe. Now if I do it in this form, then the bottom number is 54. Now how do I figure mass number? These two added up, right?
Yeah.
So that would be 135. Okay, and we know it's neutral because they match out. And then the top would be 135. Okay. Don't look at electrons to determine the element. It's either the atomic number or the protons that tell you what it is, and it corresponds to that number on the periodic table. So do the next one if you haven't done that already. And if you've done the next one, do Ag. So the element is which one? Strontium. SR. What do I look at? It's 38. Atomic number. Okay? Protons. Same as the atomic number. 38. Neutrons. We need to subtract out 38 from the mass number because that would give us the number of neutrons when we do that, because we get rid of all the protons. We're left with neutrons. So what would that be? 49. Okay, the last thing we need to determine is the charge. They're different. We got two more protons and electrons, so the charge is +2. So if we fill in the rest of this, this would be 38 would be 87 and then a plus 2. Got it? So if you've done the silver, do the bottom one. If you haven't done silver, the bottom one, finish that. So, what we have done is we went through, by the time we're done with these last two, we went through 6 examples. Atomic number on the periodic table. Protons on the periodic table. Okay? Electrons will be the same as the protons if it's neutral. If it's not, you got more, it's negative. You got less, it's positive. We don't know the neutrons. We take the protons away from the mass number. It leaves us with neutrons. If we need to find the mass number, we add protons and neutrons up. Okay? Some of you that are still going, I'm going to go ahead and give out the assignment, and you can get a head start if you know what's going on. If you're kind of finishing things up, finish them up, and we're going to go over the answer. Okay? So finish up those last two, and we'll go through the reasoning of the answer. If you're done, you kind of know what's going on, or you have a good idea going on, you can start this.
Would you put it on the calculator?
There's a number. Did you say 1? I say, what time did you say atomic number was 1?
That was super confused at first.
Okay, so I think I've given enough time. Let's go across. We got good old atomic number 47, and that equals protons. We have the electrons. Well, we'll put protons in 47. The electrons are one less, so I mean it'd be 46. So that would be there. The mass number is 108. And then when we subtract the two, we get the number of neutrons is 61. And then the charge is going to be, of course, a positive 1. The next one, we have protons is 34. Atomic number is 34. Okay. Element number 34 is good old selenium. Okay, so I'll put 34 down below. I'm going to add the two together, and that gives me what, 79? So then that becomes my mass number, 79. I know it's a minus 2. And so I'm left with electrons. And so I have to have 2 fewer or 2 more? 2 more, 36. Got everything. Okay? So now we can determine charge from the number of electrons and protons. Those are called ions. They'll come later. But now down below, number 2, there's just different ways to ask those questions that are in the boxes up here. So, like on the first one, what's the average atomic mass of zinc? That's what you guys figured on your isotope. It's the same as atomic weight. So you look at zinc and go, well, zinc, okay, is 65.38. Atomic mass is not the same as mass number. Okay? So you would put that for atomic mass. And then B, it says how many electrons will neutral atom of cesium have? So you look at cesium, you see how many protons it has. It's going to be the same. Okay? So those are type of questions that are a little different.